Hello, Mr. Hong here with a new lesson, and today we're going to be talking about 6.4 and 6.5, which is talking about solving quadratic, and also square root equations. And square root equations go nice into like the whole algebra 2 aspect because, um, well, this is like the point where we start talking about true algebra 2 concepts. And before we start this lesson, I need to go over some topics that we already know so that we can apply them to this lesson. And I want to start off by talking about opposites. Opposites. And opposites are really the inverses. And we talked about a lot of this. We talked about the inverses. We switch x to y, and we switch y to x. And another thing that we can call opposites are operations. And operations such as like addition there's this opposite to it, which is subtraction. Same thing with the multiplying and dividing. And another one that we learned is squaring to square rooting. And this is the one that we're going to be talking a lot about today because we're going to be talking about square root functions and how to solve them. And this is how we do this is a square root. Oops, sorry, my phone was ringing. So this is square root. And let me give you an example of like 3x is equal to 5 is equal to 6. Make it easier. The way that we can do this is we can get rid of the square root by squaring both sides. And the reason why we do that is to get rid of both the square root, so all this goes away, and this goes away on one side of the equal sign. And what happens is that this becomes just the inside, just this inside, is still equal to 6 squared. And this 6 squared turns into a 36 because square means 6 times 6. And this is still equal to 3x. So x has to be 12. So just a nice little reminder of what we learned from like previous lessons. So there's a rule that we have to talk about first. And if two expressions are equal, then the squares are also equal. So if I have that x is equal to 4, then we can say then x squared is equal to 16. This is true. So you can substitute your equations or your solutions into the original equation to check for extraneous solutions. And this is pretty much checking your work. And this is not anything like complex or anything. We're just going to plug in what we get for x into our equation. Okay, so let's try example 1. Example 1 says solve square root of 4x minus 1, or plus 1, minus 5 is equal to 0. Check for extraneous solutions. So I'm going to rewrite this problem real quick. 4x plus 1 minus 5 is equal to 0. What would be your first step here on how to solve for x? Because our goal is really to find x is equal to something. This is our final answer. And the way that I know that is because x is the only variable inside. So what would be your first step here? Let me just wave my hand here so that I know when to put the question. Okay. The first step you would do is get the square root of x alone, which is really just adding the 5 on both sides. So this would be square root of 4x plus 1 is equal to 5. Nice. what would be the second step here? Let me just wave my hand again. We're gonna square both sides. So if I square both sides like this, becomes 4x plus 1 is equal to 25. Okay? So we just subtract. Now we just do like a regular algebra 1 question where we just subtract 1 on both sides. So 4x is equal to 24. So x is equal to 6. And why this is important is because, well, if I have this graph right here, I'm going to draw the graph very lightly here. Before I draw this graph, what happens is that x is equal to 6 like this. And this right here be 6, where it intersects because x is equal to 6 when y is equal to 0. And what I want you to do now is to plug this in. So I'm going to use this space over here for example 2 because I'm not going to work it out. But let's plug it in. Square root of 4 times 6 plus 1, make that longer, minus 5 is equal to 0. So square root of 24 plus 1 minus 5 is equal to 0. We're going to still touch this inside first. We want to condense that first. So this becomes square root of 25 minus 5 is equal to 0. We know that the square root of 25 is 5. So 5 minus 5 is equal to 0. So this is true. So what that really means is that this right here, this is my final answer. There's going to be times where you're going to get like one answer or two answers and it's not going to work. So it's your job to know how many of your solutions are real solutions, or you have to check for extraneous solutions. So I want you to try example 2 by yourself. So try it out. I'm gonna pause the video here so that you can solve it yourself by waving my hand here like this. So let's just see. Okay, so we do 3 plus square root of 2x minus 3 equals 8. I'm going to do this really quickly. Square root of 2x minus 3 is equal to 5. 2x minus 3 is equal to 25 because we square both sides. So this becomes plus 3 plus 3. X is equal to 14. I guess I should work it out. X is equal to 28 divided by 2. X equals 14. So nice. X equals 14. Let's try number 3. Number 3. A fancier question because there's what's different between example 3 and example 1 is that now I have this X right here. So my first step of getting the square root alone, which I did for example 1, that's already done. So we need to do square roots on both sides. Oh, and the last one was solve for x. So when I do this problem again, or try this problem, square root of 30 minus x is equal to x. The way I need to get rid of that square root, and the way to get rid of a square root is by doing the opposite, which is squaring. So it becomes 30 minus x is equal to x squared. And this looks weird, right? Because we can't like do any operations with it because I cannot mix x squares with x's with just a number. So what I need to do here is actually I need a factor. And I know that because if I put everything on one side, so if I do plus x minus 30 on both sides, both these things cancel out, which just leave nothing, which is 0. X squared plus x minus 30. And this is something that we can factor. And this is going to be what we have to do because we have to solve. As in, As in, my x's need to equal a number. So the way to do that is to do a factoring tree, very similar to the first semester, where I have to list out my factors like this. And one of them is going to be negative, and the bigger number is going to be negative, or a bigger number is going to be positive. So all of these are negative. I add these all up together, and this one works right here. This one works. So 0 is equal to x minus 5, x plus 6. So x equals to 5, x is equal to negative 6. So this is true so far, but we have to make sure it's true. And the way to do that is by putting it in. And I'm going to let you check that for yourself, and you're going to tell me which one, or both, or neither, are the true solutions. So let me put my hand above my camera again so I can mark it as a question. And if you really checked it, you know that the x minus 6 is not a real solution, because if I try to plug this in, 30 minus 6, minus negative 6 is equal to negative 6. So this becomes square root of 36 is equal to negative 6. But this becomes a 6, but this is a negative 6. So this is not true. Or if you would say in Spanish, falso. The other one works. I'm not going to work that one out, but this, you have to know that only one answer is correct, which is this one right here. So try example 4, and let me wave my camera for you to show what x is equal to. So I will write like example 4, x is equal to blah and blah. Or just one or none. You can say either. Okay. So you should have got to at least to here. And then you can make this 0 is equal to x squared minus x, or plus x minus 56. And it becomes 0 is equal to x plus 8, x minus 7. So x is equal to negative 8, x is equal to 7. And this would be my answer, but this one would not work. And the way that I really know that by like shortcutting is that no square root can equal a negative number. And we know that because we introduced I. I was the way to enable us to get a negative answer when we square root stuff, because this is the square root of negative 1. But we can't type this into the calculator. Because this number is not a real number. It's an imaginary number, which is also known as irrational. So it's a concept, not a number. Kind of like infinity. Infinity is a concept. Alright, last one. Let's try it out. So we have two rationals, or radicals, in our question. So if I want to get rid of one of them, look what happens. I know that I have two squares. Sorry, square root, sorry. So I know that I have to square both of them because I need to get rid of one, right? But what happens is that the inside of the square is equal to the inside of the square root. Let me repeat that. The inside of the square root is equal to the other inside of the square root. So 2x minus 1 is equal to x plus 4. And now this is just algebra 1 right here. Algebra 1. If you have trouble solving this problem, I'll see you next year. I don't know what else to say. So minus x, we're going to add 1. So it becomes x is equal to, what, 5? Nice. And then we have to plug this in. Square root of 2 times 5 minus 1 is equal to square root of 5 plus 4. This is 10 minus 1, that's 9, is equal to square root of 9. This is true. So this works. And the last one. I'm going to let you try this one out yourself. I want you to tell me what x is equal to here. So let me just do one last question. I'm going to signal myself with the palm of my hand. Okay, let's try it out. So I already told you that the insides are equal to the insides if they're alone. So 5x minus 15 is equal to x plus 1. Because really, you would just square root both sides, or square both sides, and then the square root would just disappear. That's really the whole point of this type of question. So this becomes minus x. 4x minus 15 is equal to 1. Add 15 on both sides. So 4x is equal to 16. So x is equal to 4. And if I check this, it becomes square root of 5 times 4 minus 15 equals to square root of 4 plus 1. So let's see if it's true. Huh. Yeah, so this becomes 20 minus 15, which is equal to 5. So square root of 5 is equal to square root of 5. This right here is still true. Oh, my box is not good. This is still true. So this would have to be my answer. Alright, so you're going to have a Delta Math in your lesson, or for this lesson. Make sure you use the teacher code 182594 for Mr. Hong. And register into your correct period number, which will either be like 1st, 5th, 7th, or 8th. I'll see you guys next time when I feel a lot better. So I'll see you guys next time. See ya.